Today we're going to walk through the steps of determining the chemical formula for the hydrate, copper chloride hydrate. Now the X, Y, and Z all represent values that you're going to determine experimentally. So I'm going to walk through the steps and then we're going to go ahead and actually film the process of the lab. So from the start, we're going to need to preheat Crucible. And to preheat a crucible, the whole point is to drive off any impurities, any moisture from the crucible so that the mass is actually just the crucible itself. So preheating usually only takes a couple minutes. You always preheat before you weigh the crucible. So we're going to heat it, we're going to let it cool, and then we're going to write down its mass. Once it's cool, we're going to add a certain mass of hydrate to the crucible. And we're going to record the total mass, and then we're going to gently heat it, and gently with a small flame, and we're going to move the burner back and forth, and we're looking for a color change. Once the hydrate has completely changed color, we're going to let it cool, and we're going to record its mass again. Now the mass now indicates the mass of the crucible with the dehydrated sample. So any mass change that has occurred was attributed to water vapor evaporating out. Next, we're going to transfer the solid in the crucible into a small 50 milliliter beaker. And to make sure that we get all of the solids out of the crucible, we're going to use a wash bottle, and we're just going to spray and wash out the crucible into the beaker. The amount of water here is not that critical. It doesn't have to be a specific amount. You just need to make sure that whatever you try to get all the solids out as possible. Once we have our solution, our crucible completely rinsed out, we're going to pour that solution into a test tube. And then we're going to take a piece of coiled aluminum wire and we're going to place it into the test tube so it's submerged. And then we're going to heat that test tube in a hot water bath. When the reaction is done, we're going to see a red solid that has formed all over the aluminum coil. It's going to look kind of like a fuzzy red worm. Note that your solution at the beginning was blue, and here it's going to be clear. We'll know the reaction is done when the solution is completely clear. Then we're going to pour the contents of the test tube into a Buckner funnel, which is a suction flask, and we're going to scrape off all of the solid copper off of the wire, and we're going to try to catch all the solid coppers onto the filter paper. Now the rest of the liquid is going to flow to the bottom of the flask, and we're not concerned with that anymore. We just want the mass of the copper. Once we've scraped off all of the solid coppers onto the filter paper, we're going to go ahead and place this in the oven to dry. It's going to take a couple of hours, and then when we take it out, we're going to mask this one last time. I should have mentioned before that your filter paper that you use, you would have pre-weighed it so that you know exactly how much the filter paper weighs. So through this process, we should be able to collect all of the mass values that we need to carry out the calculation. So this is the first time that we'll be using the Bunsen burner, and I want to go over some basics. There's two ways to adjust your Bunsen burner. The first is the valve at the very, very bottom. If we turn this adjusts how much gas gets into the burner from the gas line. So if I keep turning it, I can restrict how much gas gets in, and that will essentially shorten the flame. If I open it up, it lets the full amount in. The second way to adjust the burner is to turn the actual cylinder of the burner. Now this part right here will not get hot because the flame is emanating from the top. If I turn this, and right now I'm turning it counterclockwise, notice that there's a gap, a space that opens up right here. And the more I open that up, the more noise the flame makes. And see that second inner cone right here? That makes the flame hotter. Now if I turn this clockwise, that inner cone is going to kind of disappear, and we'll have a flame that just isn't moving that fast. It's just not making that much noise. So this is a cooler blue flame. So there are going to be times when we need a really hot blue flame. Hot flames refer to the inner cone. Turn it counterclockwise until you see that inner cone. If you need a cool flame, you turn it clockwise until the inner cone goes away. Right now that's a cool flame. And you can always adjust how much gas gets to the burner from the source. So here we're connected to the gas line, and perpendicular is open. Perpendicular is closed, parallel is open. Right now it's kind of in between. If I turn this to completely parallel, it lets the full amount of gas through. But if I want to reduce this height of the flame, I'm going to turn this more perpendicular, and that's going to give us a nice small flame. So you generally don't need a really tall flame. You generally only need a flame that's about 4 inches tall for most labs. So the first step is to preheat the crucible. I have not weighed the crucible yet. There would be no point in doing so. I'm preheating this over a cool flame, and that's going to drive out any moisture, any oils, any impurities from the crucible. Now notice that I have the crucible, the lid open, partially open. That allows the surfaces on the inside of the crucible to also dry out. So I'm going to do this for 2 to 3 minutes, and then I'm going to let it cool, and then I'm going to go and weigh it. So now we're going to weigh the preheated crucible. And I know the weight on the pan doesn't read to 0. That's because there's a little bit of a draft and I have the window of the scale open. It'll calm down after I close it. Alright, so the crucible by itself and the lid, 25.695. Next, we're going to weigh out about 1 gram of our copper chloride hydrate sample. So I've tared the balance already with a weighing boat, and I'm going to scoop and get around 1 gram. If I don't get exactly a gram, that's okay. This is all relative to the mass that you're starting with. Alright, we're going to record the sample mass as 1.011 grams. Now we're going to transfer our solid sample to the crucible. So to do that, I want to minimize loss. So I'm going to fold the weighing boat and slowly pour it. Just kind of tap it down. We don't want to rush this. Might have to do some scraping. And you should check the weighing boat and see that you got it all out. Now I'm going to put the lid on, but leave it ajar. Remember, we need to dehydrate this, so the water's got to be able to leave. And then I'm going to put it under a very gentle flame so that I can pass it back and forth. I don't want to heat this too strongly. So let's turn the flame down by adjusting the gas. And I'm going to heat it like so for maybe somewhere between 5 and 10 minutes. We'll see how long it takes. I'm going to be looking for a color change. We started off with a teal blue-green color, and after it's dehydrated, it should turn brown. So after heating for about 5 or 6 minutes, our teal blue-green compound has now become pretty much totally brown, which means that this has been completely dehydrated. So now that we know the water has left, we're going to go ahead and weigh the crucible and its contents again. Alright, so the crucible and the dehydrated sample weighs 26.484 grams. Now we're going to transfer the contents, our dehydrated sample, into a small 50 milliliter beaker. And we're going to rinse it to help make sure that we get all of that compound. Notice as it's changing color back to that original teal that it was before we dehydrated it. Now we're going to transfer this to our test tube. And we're going to rinse the little beaker a little bit, just for the same reason. We want to make sure everything from the original compound gets into the test tube. So now we've got our boiling water bath. Now that it's boiling, I'm going to go ahead and shut off the heat because I don't need it to be boiling the whole time through. Going to take our test tube with solution and our aluminum wire that's been coiled. Going to drop it in and place it in the bath. And we're going to wait for 5 minutes or so until the reaction is complete. Take note of the color right now at the beginning of the reaction. Now I'm using a glass stirring rod and knocking off some of that copper that's formed on the surface of the wire. And by doing that, it's going to allow more of the copper in solution to access the metal wire, the aluminum wire, and help complete the reaction. But notice how the color, it's almost completely clear. Right, so we dissolved the copper compound at the beginning and gave it a teal color to the solution, but now the color of the solution is clear, which means all of the copper that was present is in the form of the solid copper that is now clinging to the wire. We're going to need the mass of a piece of filter paper, so we're going to go ahead and mass it. It looks to be 0.427 grams. Scratch that, 0.429 grams. This is called a Buckner funnel, and the whole purpose of this is to use filter paper that we just weighed to pour a solution that has some solids in it and filter out the solids. We used the Buckner funnel with a suction flask, which is just an Erlenmeyer flask that's got a side arm here. So we fit the flask, or the funnel, into the flask, like so. And we connect the flask to a hose, which is a suction line. And the suction line comes from the negative pressure of rushing water as water flows through the faucet. Now this is going to make a little bit of a mess and the whole countertop's going to get wet, but that's what paper towels are for. Now, before we start, the filter paper, we need to make sure that it's pressed flush against the bottom of the funnel. So I'm going to use some deionized water, get it wet, and press down the edges and make sure that we have a seal, because we don't want any solid chunks getting underneath the paper, because then they'll flow out and then we won't be able to trap them. So that's pretty good there. And so when I turn the water faucet on, it's going to create a suction. So now it's time to weigh our sample.